Welcome back. So we're going to see is a continuation of analyze malicious activity in memory using volatility. So in this lab we are going to analyze the file zeus.vmap for indicator of compromise. So what is Zeus? Zeus virus, Zeus Trojan malware is a form of malicious software that target Microsoft Windows and is often used to steal financial data like banking informations. So let's go for the practice. So the lab file is here on my desktop. So this is .vmap is a zip file, so we're going to unzip this. So the file is now unzipping. So then we can now check if there is any error message. So using this command volatility. So there is no error message. So we can see this to PID the process. So the IP address is very important. So 193.104.41.75 with the port number 80 and then 856 PID. So the volatility framework is an open source memory forensic analysis platform. So it can extract digital artifacts from volatility RAM or volatility memory samples as the system is being used. So volatility supports support memory dumps from it support memory dumps from the most operating systems, so like Windows or Linux or Mac OS or Android. So now we did check that if there is no error message. We did check the error, so there is no error message. So we can now see the process list using the volatility. So with this volatility, so and then the const scan here. So the const scan is to find the connection structure using the const scan argument. So this will find artifact from connection that were active while system memory was being captured. So the scanning is completed. So now you can see, so SV host, a lot multiple SV host is running. So it's quite strange. So what we can do now is the next phase to determine what specific process was associated with the connections to the port 80. So you noted the process ID before. So the port 80 is, and then process ID is 856. We need to find that. We need to determine the specific process that associated with the connection to the port 80. So you will get a clear idea. For that, with this command, ps list grep 856. So let's see. So normally the SV host in this window, in the Windows, the SV host is generic host-based name or name for service that run from DLLs. So in modern implementations of Windows, DLLs cannot be launched directly from Windows itself. They must be called by an executable. Each of these SV host examples are running in order to allow Windows to work with the specifically tied DLL. So now we can see here, so SV host 856 is tied here. This specific SV host we managed to find here. So now we can extract this process. So -d. So with this command we're going to extract the suspicious process. Proc dump -v -p, to that 856 space -d, capital D -tmp. So we are going to save this the temp file. So this svhost.exe process made a connection. This svhost made a connection to what seems to be possible web servers after doing a little online research on IP address to the mystery server. So you will find the various blacklist sites that the IP is registered in Molotov. So normally the IP blacklist or the blacklist or list of IP that have been reported as being involved in shady to outright malicious activity. So normally the smart admins check this list from time to time in order to formulate their own custom access control list to protect their network. So online you can find blacklist dedicated to blocking botnets, malwares, and phishing campaigns. So anyway, so now you can see here. So there is a small mistake maybe. So we map volatility. So let me check that the file is there. Yeah, the file is here. Sys -v. Yeah, there is a small mistake here. I need to use v command to get this. So yeah, there you go. So we now extracted the suspicious successfully. So what we now going to do is extract the suspicious string from memory image. How can we do this? A simple command. So output dot text, yes, is now successfully extracted. So now we can see the output here. Yeah, so there's a lot of information, I mean the strings, so it takes some time. So we can use the search command. We can grab that exact information what we need specifically. So as you guys as you can remember the IP address. So this IP address 193.104.41.75. So we can use this string as a search to search this specific item. So let's go for it. And output and grab -b2 -a2. So then 193.104. Yes, so here you go. So you can see here the embedded link, so from the image. So it's clearly, oops. So you can see here. So the link is embedded with the IP address. So this is a good sign. So we can also use the word to find that. So let's say if you want, So if you want to set using the words, you can use those. Yeah, you can also find like this. So information on the output window, from the output window. So now we can the process interaction with the system. You can use the command. We can get it from there. For that we have to use, because the SV host, the process seems the most promisingly so we have at the moment. So we should investigate how it was interacting with the operating system, operating systems and other system components. So you can use the PID at GT. So we can now look for the information if there is if we can find anything strange or is associated with the Zeus Trojan one by one. Yeah, so I can see here, so Avira 28 in this. So mutant looks suspicious. So the mutant named Avira is found, which is definitely like to Zeus Trojan. So if you Google little search in Google, so you will get more information. So when you use these keywords. So normally the mutant or mutex, as it's sometimes called, is a process handle. So a mutant is a legitimately used as a locking mechanism to serialize access to a single memory resource on the systems. The process of making each thread wait its turns for ownership of a mutant object prevents multiple threads from waiting specific memory space at the same time. So after writing at the shared memories, the owning thread will then release the mutants object, so another thread to comes along and return to memory in orderly fashion. So anyway, so we managed to find this string. Then search for the code injections. Search sorry, Volatility-yav. So we can see so now we can look for the evidence of a code injection here. So with the command, to our research, we know that the Zeus Trojan injects its code into winlogan.exe. So use the malfind command, malfind plugin, to find evidence of injected codes. So then grab for Windows grab for winlogan to see if it's included in the result, and to find what process ID it is associated. So everything you can find. So it's done already. And then there is another way also, confirm, to make sure. So with this command, uh, you can search in memory for the handle to see if any existing that match our research of Zeus indicator of compromise. So once such a file like would be sd or ea64.exe is the name of Zeus board node executable that is written to hard drive. So this is this executable is presented, so which means the virus is on the machines and the sample. So we have now successfully analyzed this. So I can see here. So what is SDRES? So SDRES is come for Zeus virus. They execute via the winlogin.exe programs. These trojans will send details to remote websites as Zeus is very bad virus that needs to be removed. So it appears on your systems via fake advertisement link, which take advantage of Windows flaws to embedded virus or spyware on your system. So report or the data is being sent to Russia or Malaysia, so not much can be done to stop this compromise activity. So you may also find the folder named WS Poems in your Windows path. So always verify your startup and the Windows machines, so you can advise the customer in the report. So this is a path. So that's it guys for this video. So we will see you on next video. Please subscribe my channel and press the bell button. Bye bye, see you.